So the next speaker is going to be Jason Bunta, who is working on the ads team at Facebook. And he's going to talk about performance and how we can make React fast. Thanks.
What's up, guys? Just got to get plugged in because we're going to do a demo. All right. Sorry about that, everyone. Cool. So I'm Jason Bunta. I'm a user interface engineer at Facebook. And I've been working on React for the last 14 years. No, I mean, it's been really grueling. You think things are hard now. I mean, you should have seen it, 2001. It's crazy. Man, I feel like you guys are all just like raging, especially Jordan in the front, from the blasphemy. Sorry. Hopefully this won't be the most blasphemous thing that I say, but we'll see. OK, so for the last couple of years, I've been working on a UI for our advertisers at Facebook using React. And it's been a really interesting experience. See, I think that advertisement is probably not the sexiest thing that it seems like you could work on, right? But I want to tell you a little bit about that because I think it's a really fascinating, very actually surprisingly human part of our business. See, we work for a really varied audience, or we try to build apps for a huge variety of people. And yeah, we work for the big guys. We work with some huge scaling problems and stuff like that, and it's awesome. But most of our people don't even think of themselves as advertisers. I mean, really, most of them are mom and pop donut shops or bloggers that are trying to promote their page, SMBs. And so being able to build a product that's accessible to everyone yet powerful for everyone is a really interesting front-end problem. And then further, just the ads in general, the technology, the work, the problems we're trying to solve in this space, I think there's some of the most fascinating and exciting and difficult at Facebook. So I don't think it's probably a huge surprise that React itself was born out of ads. And so I think Tomo took you back actually this morning to this product, ads creation. You know the story, right? It was super complex. We needed a simpler mental model. So we developed React right out of ads. So ads continues to be a place from which we develop React. We push it. We contribute to it because our apps are so complex. Seriously, it's crazy. And I actually want to show you that right now so you can see what I mean. So can you switch me over? Awesome. So this is a product that my team and I have been working on called Ads Manager. And this is live right now in production and everything. See, it looks like maybe what feels like a fairly standard interface, but it packs a lot of functionality. So I just want to go over a couple things. If I'm a local pizza shop or something, right, and I want to manage my ads, first of all, I'm going to want to make sure that I've got really interactive visualizations so that I have graphical reports and stuff. I'm going to want to economize on my screen real estate, right, no matter what device I'm in. So check it out. Ready? Boom. Boom. Yes. Right? You get excited when you work on the front end about little stupid stuff like that. Yeah. And then we have a pretty unique navigational model. And this is something that we see all the time on mobile. But it's really rare on desktop. It's just that our advertisers have some pretty unique needs, I think. Being able to sort of move fluidly between different ad levels, keep a lot of things on the page at once, this sort of nonlinear, both hierarchical and historical navigation. So it ends up being a pretty interesting problem to solve for. But then at the core of our app, we've got this like a lot of your apps have, probably a list, right? And we call ours the data table. And we built our app to be centered around this data table. We needed a component at its core that could be used for browsing and reporting, but also truly navigating. So when we built this, we needed to support everything that you'd expect out of a table. Resizable columns and varying rich data, smooth scrolling, even horizontal scrolling, variable size rows, all sorts of like sweet stuff, right? But most importantly, we needed this to work for massive data sets. I'm talking like tens of thousands of ads without blinking an eye. And we need to do that so that it performs, feels native without thrashing the DOM. So yeah, actually, you can go ahead and switch me back. Yeah. So I'm sure, like, looking at that product, like, you probably saw tons of like stuff that would be pretty fun to build, right? Like from a front end perspective, stuff I get super excited about, like CSS perf, like GPU acceleration, memory management, all this stuff, right? Some gnarly front end concepts. I would love to tell you about those things, but I'm not going to today. You can find me afterward, but really, I want to talk about stuff that I feel like people haven't really written books about. I want to talk about the ways that we can the ways that we can be intentional about structuring our app and organizing it and getting the most out of React itself when we want to take our app to the next level and really have it perform. These are some things that I don't feel like people are doing who are using React every day. Some of them are really basic, but like you need to be really like intentional about the ways you use this, and hopefully we'll learn something. So first, though, we got to establish so we're on the same page. React components, right? They're made up of a couple things, right? Props and state. All right. So super basic. We've got props, their parameters, external to our component, and state that's internal. We can put anything in there, right? We know this. This is basic React 101. Render functions look like this, and our components that have renders like this are called pure components. And we call them that because their renders are deterministic, right? They are essentially like everything can be expressed in terms of the props or the state. So even if I like blew out the function completely and had to re-render it from scratch, I would be able to do so, re-render the entire state of the world of my component because it's all expressed in props and state. So these are called pure components. And so what do we, why pure components? Like, why do we want to strive for that? Well, rendering actually is the key, actually re-rendering, which is the most expensive part of our highly interactive apps. But we can fortunately hook into this, right? We can tell React like it's got some like really key like methods that we can use to prevent React from re-rendering when it doesn't have to. Like an obvious hook is should component update. In this case, we've got should component update false. I could probably just end the talk right here. Actually, your apps will fly. But I guess we want them to be interesting too. So maybe more useful would be to do something like, okay, if we know our component's pure, we could do something like, I'm going to check the current props and see if it changes. Check the current state, see if it changes. And only if that's the case do I really need to re-render, right? So this is such a common pattern. Hopefully this isn't a huge surprise to you. We have a mixin for this. It's built into React. Check it out. It's called pure render mixin. You should all use this. It just drops in like this, and it's magical, right? If your component's pure, you can use this to separate your component from any of its parents' changes. You're insulating yourself from your parents' changes. I don't want to imply, though, that this is like a silver bullet. In fact, there's a lot of ways that you can misuse this or think that you're getting benefits out of it when you aren't. So let's jump into those real fast. So first of all, we need to make sure that we're dealing with comparable data. If we look at how pure render mixin actually works, we got to go in and we do a shallow comparison. We check, do my current props match my next props? Does my current state match my next state, right? We do a shallow comparison because this is fast, and we want this to be fast, and we can just quickly tell, right? Now, how would this work? Like in a real example, well, I don't know if this is a real example, but we got a blue button, right? We want to change it to a red button. This is really easy to do, right? You can just check. What do? We check the params, right? We check the props. Does the size change? No. Does the color change? Yes. Red and blue are not equal. React is pure render mixin really good at doing these comparisons without any problem because these fields contain data that's highly comparable. But what happens when we want to go and use more interesting data. If we want to compare something like a date, that might not be as inexpensive, right? Or we might have to massage the data a little bit to get like, date.now if we support it or whatever. And there's other like types of data that could be even trickier. That like as an illustration, like you can't just compare everything. In fact, I don't even know why you'd want to do this. But Dan talked today about, I think he mentioned something like, what about what we put in our stores? Like actual crazy blobs, like objects of nested arrays of objects, right? Like stuff that we want to use to express our business. This type of thing is hard. This is to look at this and be like, did this object in the next one change? It's hard to even tell. And should component update implementation we saw, which used a shallow comparison, it's not going to be able to do anything here. We could recursively deep compare, but that would be like, there's no point in doing something expensive when we're trying to like get a perf win here. So what can we do to compare this really fast? So I think this is one of those like unexpected times when I'm going to turn to the wisdom of the brick and mortar retail industry. I think they have something figured out. And we've all been here, this regrettable moment where we had to return that pink Barbie pony dream house. It didn't work for us. We tried, but it just didn't. So we had to take it back. The good news, though, is that like this woman knows what to do, and the store clerk, he knows what to do, right? Like, this is an established transaction that's like no surprise. If this thing came from the same store, and it's unopened, right? If we have the receipt, we can just like give it to the clerk, and he'll check it. He doesn't have to like go in the box and like look for everything. He looks at the box is sealed and like got the receipt, came from the same store, right? You get your money back. So we can borrow this concept for comparable data. When we're comparing two objects, if there was a way to like look at them and say, cool, first of all, I know that they came from the same place. I know they came from the same store or model. So I'm comparing apples to apples here. And then if there was a way to know, like, these objects are like sealed, so we don't have to look deep inside and go through that whole experience. This was really what we want, right, is referential equality, like the fastest way to compare things. And this was super easy with red and blue. These are when you're confined to primitives, everything's easy, right? But when you want to have rich data, you need to turn to an immutable model. And hopefully this is also not a huge surprise to you, but I think that when you shift to this model, it can be like really overwhelming. Tomorrow, Lee Byron's actually going to be talking about immutability, so stay tuned. It's really awesome, like a really awesome subject. But the point is, when you use immutability, you have this really powerful guarantee as a developer, trying to quickly tell if two things need to change. And that makes pure undermix ineffective, and that can make your app fast, essentially. There's like lots of ways you can do this. We actually use like a lot of native stuff, and we'll do things like be really intentional about reusing objects and like simply not mutate much. We even like throw in dev when we do stuff like that. But there's also libraries, and Lee Byron will be talking about immutable.js, which is awesome. It's got all sorts of like magical things in it that you should check out. The point is, right, immutability, we get referential equality. And when we do this like triple equals, it's like we're checking that sales receipt at the store, right? We can basically ensure that our data can be compared, and it can be compared really quickly, and that our app, like as a result, is super fast. So yeah, awesome. Now I want to move on to like, let's build something. So we saw this I demoed this table thing that we built, and this was a component that we decided right from the get-go that we wanted to do in a controlled fashion. We wanted to sort of simulate overflow auto because it was going to give us a lot of extra control. So somewhere you can imagine we've got some sort of like event handler on a wheel listener, and we're listening for we're gonna generate a stream of like scroll top values. We're going to pass that into a component. Let's just pretend this component just needs to move its contents up and down. We don't like they're just gray and white stripes, right? We can, as we slide these up and down, we'll just translate them. Building this would be simple. We really importantly only need one parameter scroll top. That's going to be changing all the time. And you can imagine we'd use like translate 3D in there, and then we get like it'd be in the GPU and cool stuff like that. The other parameters are like completely worthless and probably not changing. And this would be simple to make, but I think any CS book would probably advise us to consider like taking this a step further. And this is probably not super controversial. I mean, when we want to break this up, when we're able to separate our code, our table code from our scrolling code, we know we get a lot of wins, right? We can share with everyone. We can refactor easily. We can have a simple mental model in our head. So that's great. Separation of concerns, like always for the win, right? But I think that maybe something that's not quite as intuitive is that by doing this, we also get perf. I mentioned that like the scroll top is coming in as a stream, and we're going to use that like as something that we translate. This is like someone's finger on a touchpad, right? It's probably updating hundreds of times per second. And that means that in the top example, even if I'm using pure render mixin, I'm not going to be able to really control re-renders because the props are changing that frequently. I'm going to have to re-render everything hundreds of times per second. In the bottom, though, if I put pure render mixin on my inner table there, I'm insulating myself from all the craziness that's happening in the scrolling. And yeah, the scroller is going to do a bunch of work, and it's going to translate something up and down. But the inner table can just chill. And so, yeah, we can really get we can get a lot of wins out of this. So again, we're using by moving to this like sort of loose coupled model, we can get both performance and separation of concerns. Now, anecdotally, we experienced this when we went to build our table. We were like all done, and we were checking it out, and it sucked. The frame rate was horrible. And we dug in, and we realized that on every scroll tick, we were rendering every row, every cell, every time. So we did a little bit of refactoring, and we not only made it work and made it acceptable, but we had better organization out of it. OK, so now I'm going to talk about children. So we all know, I think, that React components are like, and their children are like, you can express them as a tree, right? And when you make a change to a React component, it's like comparing two trees. You see what's different. You find the difference between the two trees, and then you produce this update tree. The more nodes that like are in the update tree, the slower the update pass is going to have to be. And yeah, so obviously there's a risk here by having like tons of children, tons of like deeply nested crap. But also, if we imagine we have all that deeply nested stuff, it's really easy to get to the point where things get hard to maintain. And we've all been there. We're like, I need that data, right? So I'll pass it in as a prompt for my parent. It's easy for that to snowball and get to the point where, when you're like threading things down from grandparent to grandchild, suddenly you've got this like really poor separation of concerns. You've got this like deeply nested structure, this like trickle-down nesting structure that's impossible to change later because everything is like opinionated with respect to like where it is in the tree. So again, here's a risk with children. I mean, it's really easy for them to get out of hand. Another little parenting fact for you. Children are unpredictable. They change over time, every time. So what do I mean by that? I built this component here. It's all it does is it renders a section with like a child, whatever you pass in as a child. This is so in this case, like the child is a div. So I just want to render a section with a div inside. But I want to do it in a set interval and do it every 1 millisecond because that's what you do in demo code apparently. And but check it out. I'm smart, right? I'm gonna be like I'm gonna use my mixin. I'm gonna even be explicit. I'm gonna say, unless my children changed, I don't have to do anything, right? So this is like, I think this is a great like attitude, but I can tell you that despite our best efforts, this is still going to update every time, right? And the reason is because, well, first of all, it's useful to note that children are right on the props object, so they're subject to the same shallow comparisons that that pure render mixin imposes. So if we were using that, like we'd have to deal with this. But also, on every update cycle, the children object itself is not like an immutable collection. It's changing. That means that children are like, they're not comparable, not the entire object. So, or unless, maybe your children, maybe you have one child and it's like a primitive, but other than that, children are, or if you're going to compare one by one, I guess, but children aren't comparable. So when you're using pure render mixin, any hopes you were getting of any hopes of wins you were getting, they're going to be completely voided just by virtue of having children. So that's a caution. And if it wasn't clear, children are the worst. Wait, children are expensive. That's what I was supposed to say. I was going to show actually a tuition receipt or something like that, but you get the idea, right? That baby was creepy. But so they make for apps that aren't performant. And the problem is we need them, and we can't avoid them. So we need to try to minimize their use and prevent constantly swapping them out if possible. Yeah, this is like, the analogy's gone too far. Sorry. In practice, though, I'd recommend giving your children independence. This is really, really tough here. You want to get to the point where you're not passing, you're not relying on your parent to pass down everything it needs. And you need to start using even more aggressive installation between your parent and your child. I mean, we already know how to insulate from like a component from its parent. We can use pure render mixin. I want to cover another way that we could do that. This is like a stupid component. It takes some children and it puts like one on the left, one on the right. It's just like nothing more than structural markup, right? For the most part. And so after the first render, we don't even really care what happens to it. So we can be really aggressive here, and should component update false. And by doing this, we can avoid like trickle-down effects. Also, at the bottom here, I want to call it what our app actually looks like, because we do this concept all over Ads Manager. This is actually like between our body tags is something like this. We have some structural markup and then some high-level components that really contain the meat of our markup. As a policy, we make it so that all components, all high-level components that need to do any sort of data fetching, are wrapped in something that we call a container. This is like just something that we use on our team, but it's something that we enforce. So containers. So to be clear, like if I have a budget widget, I need a budget widget container. An ads targeting widget, I need an ads targeting widget container. So what is a container? A container actually does data fetching, and then it renders its corresponding subcomponent. That's it. Regular components, well, they actually render markup and styles and UI and all that stuff. They're totally data agnostic, right? So this is how we would implement something like this. Build a budget widget container. Like I said, it just renders a budget widget and passes some primitive data down to it. It implements a compute state method, and in our app, which is a Flux app, you might do something like this. You would subscribe to a store, and like you would look into, when your store that you care about changes, you'd set state using the result of this. You could also use relay, like Dan and Jing talked about, in this setup, right? You could do whatever you want. You can make API calls here. The point is, this is a data layer, this container, and when you're using that data layer, you can basically get to the point where you've got installation. If you look at the bottom, we have one thing to note is that like these containers, they don't have any children, and ideally they shouldn't even have any props. So when you go to use them, you're not having like a strongly opinionated structure, and you can like move them around. Like if our designers want to change everything on us and make it so we need to move everything all over the place, we can do that. We can actually move all over the place just by like moving, because just by like transplanting the code. No refactor required, because we don't have this like opinionated nesting structure. So and then there's other benefits too. I want to look at the widget itself. So remember, this is like a bunch of markup, right? And this is like a bunch of styles, all sorts of stuff. This is something we might want to reuse. This is, we might want to compose it with other stuff in our app, and we should be able to do that because it doesn't care where it gets its data from. Also, it probably, I don't know, another app might actually need to use it, or maybe a future app might need to use it. So at Facebook, we have multiple ads, organizations and apps and stuff, and they all maybe want to render budgets. So even though we mostly render a budget in an ads manager budget widget container, another app that has a totally different data model, totally different business logic, they can come in and use our widget without having to change anything, simply by writing their own container around it, their own data layer. And I think even more important, when we, as a policy, one of the things we do at Facebook is anytime we build an interesting component, we want to put it in our sort of internal component library so that everyone can play with, and we can see how it renders standalone. This is an environment where we don't have production data. We don't even want it. We just want to have hard-coded dummy data, essentially. So when we're there, we can basically, because of this structure, I've got this total separation, so I can drop it into this component explorer and not have to worry about relying on the stores or any sort of data dependency. And further, I can test this. I can make this automated so that my render happens on a periodic basis, and I can detect inadvertent breakages or whatever. So and Tomo said, he said this morning something like, components are the fundamental building block for building applications. We've taken that principle to the extreme. It's so true for us, especially for our designated containers. But in our app, that table widget that I demoed, I keep alluding to, literally here, every single cell is an independent application. So it has no idea about the other cells or any of the other UI elements on the page. And essentially, we're able to rely on intelligent uses of should component update for aggressive installation to prevent unnecessary propagation. And in the end, we end up with a table that can scroll really smoothly. So cool. Let's recap here. If I'm going to build an app and I want it to perform, I'm going to start with a really solid foundation of deterministically rendered components with that use my mixin, that use my should component update, my lifecycle methods, so that I can prevent needless re-renders. Doing that, I'm going to make sure that I'm using highly comparable data, ideally immutable data, coming from the same source. I'm going to build my applications as ones that are sort of comprised of smaller applications. And doing that, I get both separation of concerns and efficiency. And then relatedly, I'm going to be really intentional and careful with children. I'm going to be sure not to pass too many props or be too reliant on props. I'm going to insulate children from their parents as much as I can. And I'm going to use childless containers that talk to their stores directly so that I can prevent the entire tree from re-rendering. The last thing I want is for when one store updates for every single thing to re-render. Instead, I can have a local part of my tree, a local container subscribing to the stores it cares about. And it's OK if a subtree, or only the part that needs to, updates. But we want to avoid that case where everything's propagating. All right, so hopefully this stuff made sense. I've been talking about it at a fairly abstract level, but we've actually incorporated all of these concepts into this table. And we put it in a place we call fixed data table. And I'm really excited. Whoa. It's usually not formatted like that. But sometimes if you're cool, you could do that. So I'm actually super excited because today we're actually open sourcing this for you all to look at. So you can check it out on NPM and GitHub. And my team's been working really hard. We're really excited to actually open source a UI component. And we've been working hard to make it work for the community. We're excited, though, to see what you guys can come up with and you see your contributions and improvements on it. And we hope that it works for you. So I hope you found some of these concepts useful today. Thanks so much for your time. And I hope this stuff benefits you in your next React app. So thanks a lot.